Morning students. In continuation of Lewis Cossel approach, Lewis Cossel method and theory, we have one more important topic, types of chemical bond. Already we know about the definition of the chemical bond, the attraction forces between two atoms and the sharing of electron between two atoms. We simply called as chemical bond. Okay, simply called as chemical bonds. Okay, here we see the just in depth of chemical bond definition. The attraction forces between two atoms we call as chemical bond. That is where the attraction forces are absorbed. The attraction forces will absorb between two electrons. Between two electrons. Okay, two electrons are negatively charged particles. How attraction forces takes place? Okay, see here, while moving, this is the one atom, this is the another atom. Okay, one atom electron while moving, while forming chemical bond, one atom electron moving which direction? Clockwise direction. Another atom electron moves in anti-clockwise direction. Okay, here, which moves in clockwise direction, that value is plus of. Which moves in anti-clockwise direction, minus of. So, both are reacts with each other and form the bond like this. Okay, like this. Okay, this we called chemical bond. And atom, here atom, and here also we have the atom. Okay, the valency electrons involved in chemical bond like this. Okay, next in continuation we will see the types of chemical bonds. Okay, based on the attraction forces between two atoms, okay, chemical bonds are three types. One is ionic bond, second one covalent bond, the third one dative bond, or we called coordinate covalent bond. Coordinate covalent bond, this is also we called as dative bond. Okay, first we'll see the ionic bond. We'll discuss here about the ionic bond. Okay, what is the meaning of ionic bond and how ionic bond takes place in between two atoms? Which involves in ionic bond, which elements involves in ionic bond, we'll see in continuation. Ionic bond means the strong attraction forces between two oppositely charged ions, we call as ionic bond. Okay, what is the ionic bond? The strong attraction forces between two oppositely charged ions, we call as ionic bond. Okay, the strong attraction forces between oppositely charged ions, it is a positive charged ion, and X minus, it is a negative charged ion. The strong attraction forces between two ions we called as ionic bond. Called as ionic bond. In most probably the ionic bond is formed. M plus means it should be always metal. Okay, X minus means it always gain the electrons, means it always lose the electron. So N it should be metal. X always lose the electron, always gains the electron, so it should be non-metal. Always, okay, this ionic bond is observed in between, okay, here metal and non-metal. So this is we called as, okay, metal and non-metal bond, and this is also called, okay, in salt also, so many salts are having same this ionic structure. So this is also called salt-like bond, salt bond. Untitled bond, yeah, metal and non-metal bond. Metal and non-metal bond. Okay, see some of the important examples for the ionic compounds. The ionic compounds which have the ionic bond, the compounds which have the ionic bond, such compounds we called as ionic compounds. The compounds which have ionic bond, those are simply considered as a ionic compound. Example for ionic compounds, here I am taking some examples. Sodium chloride, NaCl we called sodium chloride. Sodium chloride. Okay, magnesium chloride, MgCl2, magnesium chloride. Okay, AlCl3, aluminum chloride. You take any one, suppose for example, what you take here, potassium chloride, KCl, potassium chloride. And one more thing, see, one important is there. Here, which is positive, which is negative. Just identify easily. Which have the ionium, those should be positive. Which have the iod, those should be negative. In salt, okay, in all salts, which have the ium, which end with the ium, those we called as positive charged particles, positive charged metals, positive charge, or we called metal. Okay, which end with the negative charge, we called non-metallic part. Okay, non-metallic part or negative charge. See here, magnesium is a positive part, it is a negative part, it is a negative part, it is a positive part, it is negative part, it is positive. Positive, negative, positive, negative, positive, negative, positive, negative. Attraction forces, strong attraction forces between two atoms we called as, okay, two oppositely charged ions we called as ionic bond. Okay, see, these are the examples for the ionic compounds. How ionic bond takes place? Formation of ionic bond. Formation of ionic bond. Okay, see, first sodium chloride. First molecule, sodium chloride. How sodium chloride molecule is formed? First write, what is the atomic number of sodium? 11. What is the electronic configuration of sodium? 1s2, 2s2, 2p6, 3s1. This is the electronic configuration of sodium. When it loses one electron, that means sodium loses one electron. It loses one electron and forms Na plus ion. Na plus ion. Loss of electrons we call oxidation. Give it that one. It loses one electron. Why it loses one electron? It is a metal. Always, what is the meaning of metal? The element which is able to donate one electron we call as metal. It donates one electron, forms Na plus ion, sodium ion. This we call sodium ion, cation. Sodium cation. What is? It is stable. Never lose one more electron. Why? Because see the electronic configuration of this one. See. Okay, what is that? Okay, what is the electronic configuration of this one? 1s2, 2s2, 2p6. One electron lost, so 2p6. It is neon electron configuration. It gets inert gases electronic configuration, or it has 8 electrons in outermost. So it is stable. It is stable. Okay, this is the first step, formation of cation. Formation of cation. Okay, next second step, formation of anion. Formation of anion. How anion forms? Okay, here anion means negative charge. Positive charge finish. Chlorine is there. Chlorine gains when here just sodium lose one electron. That electron gained by chlorine atom. What happens? Forms chloride ion. This is we call reduction. Which is more stable? The electronic configuration of chlorine 1 is to 2p6, 3s2, 3p5. If it gains one electron, what happened? 1 is to 2 is to 2p6, 3 is to 3p6. It is argon electron configuration. Argon means it has 8 electrons in alkyl motion. It follows octet principle. It follows octet rule. That means here sodium plus ion is stable, here chloride ion is stable. Both are okay. Reaction with each other. Reaction between right here. Reaction between cation and anion. See, sodium plus Cl minus and forms sodium chloride. See, the strong attraction forces between two oppositely charged ions we call as ionic bond. Okay, this is about the just formation of ionic bond in sodium chloride. Next in continuation we will see magnesium chloride, and here see aluminum chloride. We will see 3 different molecules. Formation of ionic bond in magnesium chloride. How many steps are there involving the formation of the ionic bond? 3 steps. What are those? First step, formation of cation. Second step, formation of anion. Third step, reaction between or interaction between anion and cation. Interaction between anion and cation. See here reaction. Next step, magnesium chloride. Second compound, formation of magnesium chloride. MgCl2 we called magnesium chloride. How magnesium chloride forms? See, magnesium lose 2 electrons. It loses 2 electrons and we get magnesium plus 2 ion. Why magnesium lose 2 electrons? See electronic configuration. Atomic number of magnesium is 12. 1 is 2, 2 is 2, 2p6, 3 is 2. If it leaves these 2 electrons, it gets inert gases electronic configuration. That means it obeys octet principle. It has octet principle after the losing of 2 electrons. What happened here? It loses 2 electrons now. 1 is 2, 2 is 2, 2p6. It has 8 electrons. It follows octet principle. So it is stable. Next step 1, formation of cation. Second step, formation of anion. Chloride ion is there. Chlorine gains. MgCl2 contains 2 chlorines. Now I take 2 chlorines. Chlorine gains 2 electron and forms 2Cl minus. Already said chloride ion is more stable than chlorine. Why? Because it follows octet principle. The electronic configuration of this one 1s2, 2s2, 2p6, 3s2, 3p5. By the gaining of 1 electron each atom, it gets 1s2, 2s2, 2p6, 3s2, 3p6. It follows octet principle, octet rule. So it is stable. These 2 are the stable. Both are reacts with each other. See, Mg plus 2 is there here. plus Cl minus. Okay, use crisscross method. Already we know about the crisscross method now. Okay, use crisscross method. What is this crisscross method? This is the crisscross method. Then what happened here? MgCl2 was formed. This is the formation of the magnesium chloride. Next, third one, formation of aluminium trichloride, AlCl3. Formation of aluminium trichloride. See here, first formation of cation, formation of anion, reaction between anion and cation. See, first formation of cation, aluminium lose 3 electrons. Why aluminium lose 3 electrons? See, 1s2, 2s2, 2p6, 3s2, 3p1. If it loses these 3 electrons, it gets inert gaseous configuration. Inert gaseous electronic configuration. That's why aluminium loses 3 electrons. What happened after the losing of 3 electrons? 1s2, 2s2, 2p6, okay, 2p6. It has 8 electrons. So it follows octet principle. So stable. Next, chloride. 3 chloride ions. 3 chlorides. Okay, 3 chlorines attract the gain 3 electrons and form 3 Cl minus ions. Already we know it has this electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. It has 8 electrons in outermost, so it is stable. These two are stable. Then see the reaction between aluminium plus 3 and Cl minus. Cl minus. Write the formula based on the crisscross method. Minus will come here, plus will come, plus 3 will come here. What will get? AlCl3, aluminium trichloride. This is about the formation of the, okay, yes, this is about the formation of the ionic compounds, formation of the ionic compounds. Then in continuation, we will see the here factors affecting on ionic bond. Okay, factors affecting on ionic bond. Okay, here atomic size of cation. Okay, atomic size of anion. Okay, ionization potential. Ionization potential. Ionization potential. These three are main important factors on ionic bond, effect on ionic bond. First one we'll see atomic size of cation. Okay, here I am taking sodium. Okay, sodium. Here I am taking potassium, rubidium. See, all these lose 1 electron. All these lose 1 electron and forms Na plus, Ka plus, Rb plus. Okay, all these are having octet principle. All these follows octet principle. Okay, which forms fastly? That molecule forms, okay, strong ionic bond. Here, while moving from top to bottom, atomic size, okay, while moving from top to bottom, atomic size increasing. Atomic size increases. By increasing the atomic size, the cationic size also increases. By increasing the cationic size, okay, the ionic character also increases. That means ionic bond nature directly proportional to the, indirectly proportional to the, while moving the, directly proportional to the ionic radius. Which ionic radius? Cationic radius. While moving from top to bottom, okay, atomic size increases. Atomic size increases means electron donating capacity increases. Electron donating capacity increases means the molecule, the atom easily form an electrons, easily form an cation. Okay, easily forms an cation. Easily forms the cation. See here, sodium chloride is there, potassium chloride is there, RbCl. Okay, and here cesium chloride is there, and here lithium chloride also is there. See the cation, which has more size? Cesium. So cesium easily lose the electron. Easily lose the electron and forms fastly cation. So this has more ionic character. We'll see. This is the one important question. Cesium chloride more ionic character than RbCl, than potassium chloride, than sodium chloride, than lithium chloride. Due to, what is the reason here? Due to atomic size or ionic size. Atomic size, ionic size. Atomic size increases. So, ionic nature also increases. For example, you take these molecules, sodium chloride, magnesium chloride, okay, aluminum chloride. Okay, sodium, magnesium, aluminum. These are the third period elements. While moving here to here, left to right, atomic size decreasing. Okay, magnesium, sodium atomic size more than the magnesium atomic size more than the aluminum. So sodium chloride is more ionic nature than magnesium chloride, than aluminum chloride. Here see, sodium plus, magnesium plus 2, aluminum plus 3. That means we mentioned like this: by increasing the charge on cation, ionic character decreases. Charge, see principle, charge on cation indirectly proportional to the ionic character, ionic nature. This is the one more principle. Remember this principle. From this they ask one question. NEET level or KE level or CET level, they ask one question. This is the one size of the cation. Next in continuation, we will see the atomic size or ionic size of anion. Same like, okay, see here, second one, atomic size of anion or ionic size, ionic radius of ion, ionic radius or atomic size. See here, okay, you take one group anion, fluorine, chlorine, bromine, iodine. Okay, fluoride ion, bromide ion, iodide ion. means it gains the one electron. Okay, here which gains electron fastly here? Fluorine gains fastly. Why? Because size is less. Size is less. Okay, it gains slowly after the fluorine, it gains after the chlorine, it gains after the bromine. So, sodium fluoride is there, sodium chloride is there, sodium bromide is there, sodium iodide is there. All are having same. Which gains electron fastly? Gain indirectly proportional to the atomic size. Electron gaining capacity indirectly proportional to the atomic size. Which gains fastly? Fluorine. Atomic size is less. So, sodium fluoride. Fluorine gains fast electron. So, sodium fluoride more ionic, then sodium chloride, then sodium bromide, and sodium iodide. Sodium iodide. Okay, just this is about the atomic ionic radius, and we will see charge. Suppose you will take any charge of the atoms. For example, what you take? Sodium fluoride, magnesium, okay, magnesium fluoride, and aluminum fluoride, which is more. Okay, here sodium has more than this one. This depends on cationic size, +1, +2, +3. Anionic size means, okay, here I am taking sodium fluoride. Okay, here I am taking sodium oxide, sodium fluoride, sodium oxide, and after that we have sodium nitride, Na3. Okay, sorry, Na3N. Here -3 oxidation state, here -2 oxidation state, here -1 oxidation state. By moving from left to right with the size, okay, the size of fluorine is, okay, the size of fluorine is more compared to this. So ionic character gradually increases from here to there. Okay, this is about the one more important factor affecting on atomic size of anion. Next, in continuation, ionization potential. What is the ionization potential? Ionization potential. What is the ionization potential? The energy which is required for the removal of one electron from the outermost orbit of an element from the in gaseous state we call as ionization potential. If ionization potential is less, ionization potential is less, that molecule forms fastly ionic compound. That means that molecule has more ionic character. Always NP values directly proportional to the ionic character. Suppose sodium fluoride and cesium iodide, which has more ionic nature? Here, cesium fluoride. Here cesium fastly forms cation. So cesium fluoride more ionic character than sodium fluoride. You take sodium fluoride, sodium iodide, which has more electron accepting capacity? Here fluorine. So sodium fluoride has more ionic than sodium iodide. We explain like this. These are the important properties of these are the important factors affecting on ionic bond. Next in continuation we'll see the characteristics of ionic compounds. After that we'll move into the covalent bond. Thank you.